We're going to talk about 12.3 trig functions on the coordinate plane. This is our biggest piece of info here. So if we take our, I like to draw a new one. If we take a point on a circle, it said this is x, y, and we go x units right, y units up, and r units on a hypotenuse. We put the Pythagorean theorem in play, x squared plus y squared equals r squared. And then we also have a way to write every single sign. I just go with these ones. The other ones will come along for the ride in terms of reciprocals. Remember, we don't necessarily have to memorize those. We need to understand them. So you have x coordinate, y coordinate, and you're always talking about this reference angle right here. That's going to be important. Opposite over hypotenuse means that sine will be y coordinate. Adjacent over hypotenuse means that tangent will be, or the x coordinate over the radius will be the cosine. Now, one thing about sine, cosine, and tangent, as we look at these different ratios, I like to call it chilling in the STC. If you think about sine being a y-coordinate, the y-coordinates are going to be positive in quadrant 1 and quadrant 2. For that matter, we don't have a letter in quadrant 1 because everything is positive in quadrant 1, and we should understand that. But quadrant 2 is above the x-axis, so the y's are positive. So these letters are which of the sine, cosine, and tangent will be positive in each individual quadrant. Down here, the cosine is positive in quadrant 4 because it's the x-coordinate. And the value of r will always be positive because we are talking about the Pythagorean theorem, which means we had to square two values and then take the square root of the sum of them in order to get the value of r. The tangent is positive in quadrant 3 because it's the y-coordinate opposite over the adjacent. So this all runs off of SOHCAHTOA. Opposite over adjacent. This would be a negative divided by a negative. So you can tell the sign of a positive or negative of sine, cosine, and tangent just by knowing the quadrant that it's in. That's going to be quite important. If we do something like this, I would go 8 right, 15 down. Pythagorean theorem would give us 8 squared plus negative 15 squared equals r squared. 64 plus 225 is r squared. R squared is 289. R is 17. So if I know that I have an 8 negative 15, 17, I can go sine of the angle. Again, we're always going to go off of this guy right here. This is the angle coming around, but we're using this triangle. That's going to be our reference triangle. So we're going to go opposite over hypotenuse, and then we're going to go cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Oh, look at that. We fulfilled the STC. The cosine should be the one that's positive. So you can actually just do 8, 15, 17 and then fill your signs in from this guy. And now we got to flip. And when we flip, we go cosecant. Just flip this guy. Nice. And then we go secant. Just flip the cosine. And then we go cotangent. And obviously, if you're doing a reciprocal, the positives and negatives come right along for the ride. So there you go, using a reference triangle and quadrants in order to get our stuff together. Find the exact values of the 6 trig functions of the terminal side that contains negative 3, 4. So if I'm going to go negative 3, 4, I go 3 left, 4 up. Hey, look at that, I'm in quadrant 2. And I can also recognize this as a 3, 4, 5. That's a thing. And if we think about this, we know that we're in quadrant 2, sine will be positive. The sine, so you can tell right away, sine 4/5, cosine negative 3/5, tangent -4/3, flip them, cosecant 5/4, it's that guy, secant -5/3, flip it, cotangent -3/4. Now we're cooking with gas. Good stuff. Okay, these are going to be called the quadrantals. The quadrantals are going to be a little bit more confusing. Now, you can use what we just had up there. You can use y over r, cosine is x over r, and tangent is y over x. But we don't necessarily always remember those. So one thing we can do here is we can draw triangles that do not exist. Okay, so I can say if I'm going to be at a point where I'm r units to the right, I could draw a triangle that goes r to the right, 0 up, and has a radius of r. So you can fake yourself out and still use SOHCAHTOA. These are called the quadrantals. They fall on the axes. So you have, this is 0 degrees, 90, 180, 270. Let's take a look at an example, and I'll show you what I mean about the fake triangle. Now, if I understand how 0, -2 works, 0, -2. First of all, if I had an r going around, the r would be equal to 2. So I have an x and a y and an r. So if I go off of what we had done earlier and say y coordinate, -2 over r, +2, the r is always positive, I get -1. And I get cosine is going to be the adjacent, or the x coordinate over the r, and I get 0 over 2 is 0. And the tangent is going to be the y coordinate over the x coordinate. Holy cow, you're not allowed to divide by 0. It's going to be undefined. And when we flip these things over, we'll get the other three. We'll get the cosecant flips over the sine. Flip over -1, you get -1. Secant flips over the cosine. Flip over 0, you get undefined, 2 over 0. Flip over the tangent, and you get 0. You flip over undefined, and you're going to get 0 over -2. Okay, so that's using the coordinates, but I find that people don't really like that much because it's like a little bit confusing for them, and I don't want to confuse you. So let's draw a triangle. I go 0 to the right and down 2, and I know that my radius would have to be 2. So I draw my theta in there, and I say sine is equal to opposite over hypotenuse, and I get it. And cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so can you really go 0 units to the right? Absolutely not. But you can trick yourself into opposite, adjacent, and hypotenuse and make this go. And then when we flip this over and flip this over and flip this over, you get your cosecant, your secant, and your cotangent. Let's try another one of those. 3, 0. 3, 0. Again, fake triangle. 3 to the right, 0 up. Can you go 0 up? Absolutely not. So we're actually out here at 0 degrees. And then I go a radius of 3. Well, which of the following is incorrect? Well, here's my angle. Sine would be opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So I get sine is 0. Well, this one fails. Cosine is 1. That one's good. Tangent is 0. That one's good. If the tangent is 0, then the cotangent is undefined. That one's good. So you can see how to work those off of a fake triangle. Reference angles are always formed with the x-axis. So reference angle is the acute angle formed with x-axis. So we have to obviously in quadrant 1 it's the angle given. In quadrant 2, if this is 150, this is 30. In quadrant 3, if this is 240. This little angle is going to be 60. Quadrant 4, if this is 315, the reference angle is 45. And that's what you're going to use in order to solve for some exact values. Sketch the angle, find its reference. So I'm going to sketch 330, but my reference angle is 30. And that's going to be key, because the next thing we're going to do is we're going to go 30, 60, 90. 1, 2, square root 3. And we're going to go STC. And we're going to say, I'm in quadrant 4. Find me the sine of 330. And I'm going to say it has to be negative. And I'm going to say use a 30-degree reference angle adjacent over hypotenuse. And we're going to say square root 3 over 2. Or excuse me, that should have been 1 over 2. That's what you get for doing a problem that's not really there. Negative 5 pi over 6. A few different ways you can look at this. I'm a pi over 6 short of getting to 6 pi over 6. So I'm a pi over 6 short, which will give me my pi over 6. But most of you don't like radians because radians are annoying to you. I love them. If you want to get rid of radians, you put pi radians on the bottom and you put 180 degrees on the top, and you cross out and you cross out and you go 30 and you go negative 150, and you think to yourself, negative 150 leaves me 30 short. Well, what's 30 in radians? I can't remember. 30 degrees in radians is going to be 180 pi radians. Oh, 30, oh, 3, oh, it's pi over 6. Oh, I was right in the first place. Isn't that amazing? The reference angle is 30 degrees because it's pi over 6. So convert it over, find your reference angle, convert it back. I know I did that one fast, but you're going to have an opportunity to practice a few of those in the homework. It's a good time. 315 and sketch its reference angle. You're probably thinking, well, I'm 45 short of 360, and you're right. It's very important that you understand that the reference angles are always going to be drawn with the x-axis, because the next thing they're going to do for you is ask you to find, well, here's another one. I'm 45, pi over 4 short. This one's going to be pi over 4. You can check it out by, that's the reference angle. The angle itself is negative 135. This is the STC I was just talking about. So we don't do this big nasty thing. We say the sine is positive, the tangent is positive, the cosine is positive, and everything is positive. It's way easier than using this one. So when we find an exact value, what we're going to do now is we're going to need a couple of things hanging around. You're going to need your exact value, means 30, 60, 90. 1, 2, square root 3. And then we also need the 45, 45, 90, 1, 1, square root 2. And we need the STC. We need that for all of these problems now, because I'm going to go to 135, and I'm going to be in quadrant 2, and I'm going to be a 45-degree angle. So really I need the sine in quadrant 2 is going to be positive because of this. And then I go to 45, it's 1 over the square root of 2. Multiply the top and the bottom by the square root of 2, and it's square root of 2 over 2. There's my exact value of the sine of 135. It goes, get the reference angle, 45, pick your triangle, and then use your STC. 7 pi over 3. The first thing I need to do is figure out what 7 pi over 3 is. 7 pi over 3 times pi 180 pi 60. It's 420 degrees. And I go 420. I went 60 past. Oh, my reference angle is 60. I don't like cotangent, so I'm going to find tangent. STC 30, 60, 90. 1, 2, square root 3. Tangent is square root 3 over 1. But I'm in quadrant 1. Everything is positive. If the tangent of 60 is square root 3 over 1, then the cotangent of 7 pi over 3, which is exactly the same as the cotangent of 60, will be equal to 1 over the square root of 3, and I multiply the top and the bottom by the square root of 3. And there we have it. Lots of practice with these ones. Sine of 120, quadrant 2. Quadrant 2, 120, 60-degree angle. Get your 30, 60, 90. And I know I've got sine is going to be square root 3 over 2. And in quadrant 2, I'm positive. I'm looking for positive square root 3 over 2. We got it. Oh, these are fun. What a great time. We're going to stop right there. And that is it for 12-3.